No.
No, and then she's like, I could actually hear all these years.
All right, so polynomial equations. All right, so we talked about the degree of a term of a polynomial. For example, this is a third degree polynomial, right? 2x to the third. X by itself would be a second degree, or first degree. XYZ would be a third degree polynomial, right? Remember talking about that? All right? And those are all monomials. And we also talked about in a polynomial, the degree of the polynomial is always the one that is the biggest. So this one that I just wrote up on the board would be a which degree polynomial? Okay, that's a third degree polynomial. All right, if we connect two polynomials with an equal sign, we have created a polynomial equation, which is what we're talking about today. So how about x to the fourth minus 3x squared plus 2 equals 0? That's a fourth degree polynomial equation. Okay? Fourth degree. This is a first degree. Y equals 2x plus 4. That's a first degree polynomial equation. And we're going to take a special look at this equation here, the y equals 2x plus 4 today. In a first degree polynomial equation, so this is first degree, the first degree polynomial equation, there's an infinite number of values that we can use for x and y to come up with a solution. All right? So somebody assign me a value for x.
5.
5. Okay, so it means we can come up with a solution for whatever x is by inserting 5 into it. So y equals 2 times 5 plus 4 would be y equals, what's the answer? 14. So whatever we put in for x, we can get a solution for y. There's an infinite amount that we can come up with. All right, does that make sense? We can prove it. We can prove it in the original equation by plugging in the numbers for what we just said. So 14 for y and 5 for x. Does this, and this means that 14 equals 14 as a proof. Right? All this is telling us so far is that we can replace x with any real number and get a value for y and make this equation true. All right, and there's a couple terms that we need to know. We assigned a value to x, correct? Yes? All right, so x is an independent variable. Independent variable. X is an independent variable because we could pick any value we want for x. But because we do that, that makes y a dependent variable. So y will become dependent because it matters what x is to give us what y is. Y relies on x. So that's y is dependent. It depends on x to be something. We can pick whatever we want for x, but y has to be something. All right? Make sense so far? Yeah? Yay? Nay? Good? All right. All right. When we do that, we just created a value for x and y. And we can arrange that in ordered pairs. Eventually, we're going to graph this stuff. All right, so our ordered pairs for this one, I'll just write ordered pairs here. Ordered pairs. My brain had a cold moment. Which one was the x? What do we say x was?
5.
That's always the first number in the pair. Which one do we say y was?
14.
Because that's what the answer turned out to be. So you can arrange the solutions to all these equations into ordered pairs. Always writing the x first, the y always comes second. Cool with that part? Here we go. We resumed. We resumed. All right. With our ordered pairs, let's move this back this way. What was the ordered pair that we created?
5, 14.
Okay, we created 5 and 14. So that was our ordered pair. We could easily graph what 5 and 14 were. Starting at 0, go 5. Oh man. Let's change this back because I have to go way. There we go. Now I got it all up there. So 5 and 14. So always starting at 0, 0, going over to 5, all the way up to 14. I just lost my 5. There it is. Okay, so we can graph that point. That easily. Right? Okay, so information, this should be reviewed. There should not be any new stuff here. But this is called, let me move this back, down. And then I'll get rid of that. Okay, so this is the first, this is the first quadrant. The first quadrant is always positive, positive in your ordered pair. First number is always positive and so is the second number. This is the second quadrant. That's always negative, positive. First number is always negative. The x is always negative. The y is always positive. This is the third quadrant down here. These are always both negative. X is negative and so is y. And this last one is the fourth quadrant, where the x is positive and the y is negative. Easy enough? All right, so let's graph a few things. Where is 3, 3?
3, first quadrant.
Okay, so the first quadrant, starting at 0, 3, 3. I know you know this. This is going to become dicey later on, so we want to make sure we got the foundation laid. 3, 3. What's the second one? Negative 4, 0.
It's on the line.
It's right on the main line. It's right on the x-axis. 4 over doesn't go up or down. 0, negative 3.
Negative
On the line, on the bottom.
Yep. Very good. And then the final one, 4, negative 2.
4th quadrant.
Yep, so in the fourth quadrant. Okay, does that make sense? Easy stuff, right? This is all today. It's all foundation. Later on, we're going to be doing, like, next week, tomorrow, I should say, we're going to do a lot more with the graphing part of these. It'll still be easy for a little bit, and it'll get more complicated later. We'll start with the easy stuff today. All right? Because all algebra is, it's a bunch of easy stuff put together into something hard. Cool? Cool. It didn't sound it. And 3.